Welcome to operating systems class. We shall continue our module 3 memory management, and today's topic is demand paging. We are now in the virtual memory concept. In that we saw the virtual memory basics in the previous class. In this class we shall continue with our next topic. Demand paging, in this according to your syllabus you will be studying paging hardware and virtual memory handler. In order to know that, we need to know those concepts, we need to have some awareness of the few basic things. Even though this is not in your syllabus, we shall have look into the basic things. Okay. We know that process consists of pages. Okay. And the pages are numbered from 0 to n. Each page is having a size of s bytes, and s is nothing but a power of 2. This we already know from the previous classes. And we also know that there will be a page frame. Correct, there will be a page frame. The memory of the computer system is considered to consist of a page frames. We took an example in the previous class, in one of the class, and we came to know what is page frame and what is free frames and all. Okay, the page frame is nothing but a memory area that has same size as of a page. Whatever the page is having a size, same size the page frame will have. Page frame is nothing but a memory area. Page frames are also numbered from 0, but they will be the last page frame will be n frames minus 1. If there are 10 frames, so last frame will be 9. Okay, n frames equals to 10, so it ranges from 0 to 9, where n frames the number of page frames of a memory, number of page frames, that is, as I said, 10 frames. Okay, that's for an example. So, and coming to physical address, the physical address consists of the addresses from 0 to n frames into size of the page minus 1. We said the page frame size will be same of the size of the page. So the physical address space means the exact address. So its range will be 0 to n frames into s minus 1. S is nothing but the size of the page. At any moment, a page frame may be free or it may be occupied by some process. And the logical address space, we know that it comes with a pair, that is pi comma bi, where p is the page and p is the page number and b is the byte size. Okay, and vi ranges from 0 to s. S is nothing but the size of a page. And this is an address translation way of a virtual memory using paging concept. We already come across this. Here we need to look into the few things. One is the memory, and other is the MMU, and the page table construction, the free frames. Okay, we shall try to understand one by one this figure. Okay, this is a schematic diagram of a virtual memory using a paging, and each page size is assumed to be 1 KB. We know that 1 KB is equal to 1024 bytes. Let us try to construct this. Here we address translation means obviously we are considering the logical address space, that is in pair pi comma bi. If you see that there is a memory of 8, in the fifth area you can see the instruction add. So on 2 in add, see there's an instruction where it is divided with some squares. Add is 1 square and 2 is 1 square and 480 is 1 square. If you look this, add means address. If you look into this, 2 is pi, 480 is the bi. Okay, so page 2, it will pi is page 2 is 2, sorry, page is 2 and b is 480. So this information will be collected with the MMU for address translation. So MMU reads this as 2 as the pi and bi as the 480. And when we take some processes, so we need to construct the page table of a process. So there will be 3 processes, P1, P2, P3. So we'll be constructing the page table for each of the process. Page table of P1, page table of P2, and page table of P3. Hope I'm audible. Okay, and if you look into this, there is the page 1 is sorry p process p1 is having a pages 4 0 1 2 3 4 pages, and page 2 is having a 5 pages 0 1 2 3 4, and page 3 is having a 5 6 pages 0 1 2 3 4 and 5. If you see the 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 page 0 and page 2 are occupied by 4 and 1 page frames. Okay, in page process p1. In process p2, page 1 is occupied by page frame 5, page 2 is occupied by page frame 7, and in page table of p3, page 1 is occupied by page frame 0, page 3 is occupied by page 2, sorry, page frame 2, and page 4 is occupied by page frame 3. So which one is the left out? That will be the in that page frame will be in the free frame list. Okay, so number 6 page frame is left, that will be in the free frame list. So in address translation, we'll be having a memory with instruction. That instruction will be used by the MMU for address translation from, and that instruction will be used, and the page table is constructed, and from the page table we can obtain the number of page frames occupied and number of page frames are free, and whichever the free, which will be, it will be placed in the free frames list. Okay, this is just a general idea. Then coming to this translation, if you see pi is 2 and pi is 480, and this process and this picture is showing that the 2 will be replaced with the 7, 2 will be replaced with the 7. Okay, so the qi will become 7 and the size will remain same as it is. How, we shall see in the upcoming slides. Okay, please see the dotted lines and the arrow mark also. Okay, okay, we shall move. See, the page number 2 is been taken and it is replaced by the corresponding page frame. Okay, in page 2 there is a page frame called page name numbered 7. That's that page frame will be shown in the MMU. Okay, and the size will be retained as it is. Okay, if you are wondering how the 7 is coming, because at page 2 in the process p2 table, page 2, there's a page frame 7, page frame number 7 is there, that will be replaced here in the qi. Okay, so we took 3 processes p1 p2 p3 and we constructed page tables. Okay, and we took a memory having 8 page frames from numbered from 0 to 7. Okay, and we constructed page table for each of the process, page table of p1, page table of p2, and page table of p3. Okay, and each in the each page table we saw the page table entry, that is page frame numbers in the corresponding pages. Okay, we know we defined that page frame is nothing but a number where a page resides. Process P2 has its pages 1 and 2 in the memory, and they occupied page frame 7 and 5 and 7. This we already looked in the figure. Same thing we are detailing in the words in a sentence. Okay, process P1 pages 0 and 2 are occupied by page frame 4 and 1, while process P3 pages 1 and 1, 3 and 4 are occupied by page frame 0, 2 and 3 respectively, and the free frame list contain the page frame 6. If you want, we can go and check once again the wordings. This is the process page table of p1, where page 0 and page 2 are occupied by page frame 4 and 1, and page table of p2 process, page 1 is occupied by page frame 5, page 2 is occupied by page frame 7, and page table of p3, page 1 is occupied by page frame 0, page 3 is occupied by page frame 2, page 4 is occupied by page frame 3. This is the same thing we detailed in the wordings. You need to write because you need to get the marks. Okay, you have to write this information. If you, after drawing the diagram, you need to write this information so that you can fetch the marks. Okay, continuing to this, there was an instruction add to 480. Okay, when we execute that instruction, we'll be getting 2528. How it is getting? Because we took size as 1 KB. So how many pages are there? 2 pages. So 2 into 1024 we need to perform. 2 into 1024 plus 480 we need to perform. Okay, 2 into 1024 plus 480 will get 2528. Okay, that is how we are getting the address translation. Okay, the MMU will uses the P2 information to 480 and provides an address translation with 2528. Okay, and thus we saw that page 2, at page 2 there is a page frame number 7, it will be replaced there. Okay. Further continuing, we can obtain the effective address by replacing the after replacing the page number with the page frame number. Okay, we replace page 2 with its page frame number 7. So effective address will be 7 into 1024 plus 480. Okay, this is how we calculate the address and the effective address. Okay, now we can able to access the memory easily. Okay, that's about the demand paging basics, and in the next class we'll be learning about the two concepts according to syllabus, that is paging hardware and VMI. Okay, we'll meet in the next class. Thank you all.